Hey guys, in today's video, I'm going to solve all the important questions from the NCERT textbook for the chapter integrals. So let's start. Exercise 7.1. The first important question is question number 10, which is given as root x minus 1 by root x whole square, and we have to find the integral of this. So integral of this dx. So the first thing we are going to do is we will use the a minus b whole square formula. So this can be expanded as x plus 1 by x minus 2 into root x into 1 by root x. So root x and root x gets cancelled. So we are having x plus 1 by x minus 2 dx. Now we know that integral of x is nothing but x to the power n plus 1 by n plus 1. So x's integral would be x square by 2, and 1 by x's integral should be log x minus 2's integral would be 2x plus c. So this is your answer. Let's do the next question. The next important question is question number 13 in the textbook. So question number 13 is integral x cube minus x square plus x minus 1 divided by x minus 1 times dx. So in this question, what we are going to do is take common x square from the first two terms. So you would get x minus 1, and you can write it as 1 into x minus 1 whole divided by x minus 1 dx. So the key here is to simplify it in a way that it becomes easy for us to integrate. So x square plus 1 into x minus 1 divided by x minus 1. X minus 1, x minus 1 cancels out. You're left with x square plus 1 integral. So the answer for this would be x cube by 3 plus x plus c. Let's move ahead to the next important question in this exercise, which is question number 16. So the question is integral 2x minus 3 cos x plus e to the power x dx. So integral of 2x is nothing but 2 into x square by 2 is the integral for 2x minus 3 cos x. So minus 3 integral of cos x is nothing but sin x, and integral of e to the power x would be e to the power x plus c. So this is going to be the answer. Let's go ahead and try question number 17 now. 17, not 17, question number 18. So question number 18 is given as secant x into secant x plus tan x dx. So in this question, if we just expand this, that will give us an idea as to how to integrate. So secant x into secant x would be secant square x plus secant x into tan x would be secant x tan x times dx. So integral of secant square x is a direct formula. Integral of secant x is nothing but tan x. Sometimes if you're struggling to figure out the formula, just remember all the trigonometric formulas and what their differentiated value is. So derivative of tan x is secant square x. That's how you can connect these two. And then secant x tan x is nothing but going to be secant x, because differentiation of secant x is secant x tan x plus c. Another very important tip is, if you're ever not sure about your integral answer, always differentiate it and see if you're getting the question. If you differentiate it, then you will get the same question, and that should be your answer. And that will confirm your answer is correct. Let's move ahead to question number 22 of this exercise. So this is a multiple choice question. Here they're saying if d by dx of f of x is given as 4x cube minus 3 by x to the power 4, then what is f of x? So the derivative of this is given. So we, to find f of x, we have to integrate this function. So integral of this function would be 4 into x to the power 4 by 4 minus 3 into x to the power minus 4's integral would be x to the power minus 3 by minus 3. So this is going to be minus 3 gets cancelled, 4 gets cancelled. So x to the power 4 plus 1 by x cube should be your answer. Differentiate it, see if you're getting the question. So differentiation of x to the power 4 is 4x cube. Differentiation of x cube would be minus 3 by x to the power 4. So this is the answer plus C. So that should be the answer of your question. But there is one more additional step over here. They have said that f of 2 is equal to 0. So this means that when we substitute the value of 2 into this function, we should be able to get the constant. So let's apply this. 2 is equal to 2 to the power 4 is 16 plus 1 by 2 to the power 3 is 8 plus C. So 16 times 8 would be 48 and 8 and 4 is 12. So 128 plus 1 by 8 plus C is the equation. So C is going to be equal to minus 129 by 8. So your final value of f of x should be x to the power 4 plus 1 by x cube minus 129 by 8. By looking at the answers, I can see that option D is the correct answer with the options A is the correct answer. So that is your answer of this question. Now let me go ahead to the next exercise. The next exercise we'll be doing is 7.2. So all the important questions from exercise 7.2, starting with question number 5. Question number 5 is sin ax plus b times cos ax plus b. So exercise 7.2 is about the integration technique called substitution. So here we have to figure out which function is the one that we want to substitute. Now there's a clear pattern in such questions. Typically, if it is a function where it's f of x times f dash of x dx, then the substitution value should be f of x. So in this case, sin x's derivative is cos x. So I'm going to say let t equal to sin ax plus b, and derivative of that is cos ax plus b. So dt by dx would be cos ax plus b times a, and I can take the dx to this side and I can take the a to the other side. So dt by a is equal to cos ax plus b dx. So this cos ax plus b is going to be dt by a, and t is equal to this. So we can substitute both the values, t dt by a. So t dt by a integral would be t square by 2a plus c, and we resubstitute the original value, which is sine square ax plus b by 2a plus c. So when we differentiate this, we are going to get 2 sine ax plus b into cos ax plus b into a. So all of it will cancel out and we will get the original question. Now, let me go ahead with the next important question. I skipped an important question before this. Question number 3 is also an important question. So we have x plus x cos x, sorry, x plus x log x in the numerator, and we are going to try to integrate this. So first thing is I'm going to simplify it by writing it as 1 by x into 1 plus log x. Now in this, 1 plus log x is, when we differentiate it, we would get it as 1 by x. So this is in the form of integral f dash of x divided by f of x, and typically integral of such things, we would be substituting the denominator, and the integral value would typically be log f of x. So let's figure out if we can do the same over here. So in this, f of x is 1 plus log x. So your t value will be 1 plus log x, and dt by dx is going to be equal to 1 by x. So you can write dt as dx by x, and then when we substitute all the values over here, we're getting 1 by t dt, because this is dx by x. So integral of 1 by t is nothing but log t plus c, and t is 1 plus log x. So your final answer would be log of 1 plus log x plus c. Now let's move ahead with the next question. Question number 7. Question number 7 is x root x plus 2. So in this question, we have a root, and we want to get rid of this and make it an easier function, because it's very difficult to integrate x plus 2. So what I'm going to do is, let's start with t is equal to x plus 2. So dt by dx is going to be equal to 1. So dt is equal to dx, and also x is equal to t minus 2. So essentially we are able to rewrite it in a way that it becomes easier to integrate. So t minus 2 times root t into dt should be the value that we're trying to integrate. So this becomes t root t minus 2 root t dt. Now t root t is nothing but t to the power 3 by 2. So t to the power 3 by 2 minus 2 to the power 1 by 2 is what we're trying to integrate. Let's see if we can do that. So this becomes easily t to the power 5 by 2 by 5 by 2 minus 2 into t to the power 1 by 2 plus 1 would be 3 by 2 by 3 by 2 plus c, which can be 2 by 5, and t is nothing but x plus 2. So 2 by 5 x plus 2 to the power 5 by 2 minus 4 by 3 x plus 2 to the power 3 by 2 plus c. So that is your answer for this question. All right. So let's move ahead to the next question. Question number 10 in the exercise. Here we have 1 by x minus root x is the integral. Now let's try to figure out if we can take something common. So I can take root x common over here, and I would get root x minus 1. Now if you observe carefully, root x minus 1's derivative is 1 by 2 root x. So it is in the form of f dash x by f of x, f dash x by f of x. So in this case, let us take t is equal to root x minus 1. Then dt by dx would be 1 by 2 root x. So dt would be equal to 2 dt would be equal to dx by root x. So over here, this can be dx by root x can be substituted as 2 dt, and this would be 1 by t into 2 dt. So integral of 1 by t is going to be log mod t, 2 times of this plus c, and as we have taken t as root x, this would be 2 times of log mod root x minus 1 plus c. Let's move ahead with the next question now. The next question is question number 11. Question number 11 is x by root over x plus 4. So here what we can do is similar to one of the questions we just did. You can take t as x plus 4. So x would be equal to t minus 4, and dt by dx would be equal to 1. So dt is equal to dx. So here we can directly substitute dt and dx and t as well. So we will get t minus 4 divided by root t into dt. Now the goal here was to simplify it, and we are able to do that in this way. So let's just divide individually by splitting them up. So t by root t minus 4 by root t times dt. So t by root t is nothing but root t minus 4 by root t dt. This is nothing but t to the power 1 by 2. So integral of t to the power 1 by 2 would be t to the power 3 by 2 by 3 by 2 minus integral of 4 t to the power minus half would be t to the power 1 by 2 divided by 1 by 2 plus c. Now you can just rewrite this as 2 by 3. T is nothing but x plus 4. So 2 by 3 x plus 4 to the power 3 by 2 minus 4 root x plus 4, and this would get multiplied by 2. So this would be 8 root x plus 4 plus c. This is your final answer. Now I'm going to move ahead to the next important question, question number 14. Question number 14 is integral of 1 by x log x to the power m dx. So over here as well, we know that derivative of log x is 1 by x. So this is nothing but f of x times f dash x. So we can take t is equal to log x, then dt by dx would be equal to 1 by x. So dt would be equal to dx by x. So let's substitute that. So we would get 1 by t to the power m into dt. So 1 by t to the power m is nothing but t to the power minus m dt, and integration of this would be t to the power minus 1 m plus 1 divided by minus m plus 1 plus c, where t is nothing but log x. So this is going to be log x 1 minus m divided by 1 minus m plus c. The next question is question number 19. Question number 19 is e to the power 2x minus 1 divided by e to the power 2x plus 1. This is what we need to integrate. Now, if you try to see a pattern, denominator's derivative is not the numerator. So, in such case, we are going to divide both the numerator and denominator by e to the power x. So, dividing both numerator and denominator by e to the power x, we would get e to the power 2x by e to the power x, which is e to the power x, minus 1 by e to the power x would be minus e to the power minus x divided by e to the power x plus e to the power minus x. And now if you see, the denominator's derivative is the numerator. So this can be your t value. So t is equal to e to the power x plus e to the power minus x. Then dt by dx would be e to the power x minus e to the power minus x. So dt is equal to e to the power x minus e to the power minus x dx. So the entire numerator is nothing but dt divided by t. So the integral of this would be log mod t plus c, where t is nothing but this is log e to the power x plus e to the power minus x plus c. Now let's go ahead to the 20th question. 20th question is also similar. You have e to the power 2x minus e to the power minus 2x divided by e to the power 2x plus e to the power minus 2x dx. So here if you see, the numerator's derivative and the denominator's derivative, differentiation of denominator is giving you the numerator. So t would be equal to e to the power 2x plus e to the power minus 2x. So dt by dx would be 2e to the power 2x plus 2e to the minus 2e to the power minus 2x. And we can take 2 common, so this would become dt by 2 is equal to e to the power 2x minus e to the power minus 2x dx. So when we go back and substitute it, this would be just dt by 2 into t. So integral of 1 by t is going to be log t. So log mod t by 2 plus c, where t is nothing but log e to the power 2x plus e to the power minus 2x divided by 2 plus c. Now let's move ahead with the 22nd question. 22nd question is a trigonometric question. Secant square 7 minus 4x. So we already know secant square's integral should be tan x. So this is the part that we would have to substitute. So t would be equal to 7 minus 4x. So dt by dx would be equal to minus 4, or dt by minus 4 is equal to dx. So let us substitute it. So we'll get secant square t into dt by minus 4. Secant square t is integral is tan t. So minus tan t by 4 plus c. And t is nothing but 7 minus 4x. So this would be minus tan 7 minus 4x by 4 plus c. Now, common trick is anything while differentiating when you multiply using chain rule, here chain rule value would always come in the denominator. So that is how you can use this trick to figure out the answer. Let's do the next important question. It is question number 26 from the textbook. So this is cos root x divided by root x. So the value of cos is not being differentiated, but the root x value is what we see in the denominator. So that is the substituted value. So t is going to be equal to root x. Then dt by dx would be 1 by 2 root x. So 2 dt is equal to dx by root x. After substituting, I will get cos t dt by cos t into 2. So 2 cos t dt, and integral of cos is nothing but sine. So this would be 2 sine t plus c, and t is nothing but root x. So this will be 2 sine root x plus c. Let me move ahead with the next important question, which is 29. So 29 is given as cot x log sin x. Now, if we observe carefully, differentiation of log sin x is nothing but 1 by sin x into cos x, which is nothing but cot x. Meaning, this is f of x and this is f dash x. F of x and f dash x. This means that t should be equal to log sin x, because you take the f of x as the main thing that you're substituting. So dt by dx would be 1 by sin x into cos x, which is nothing but cot x. So cot x dx is equal to dt. So we can just write this as t dt integral. Integral of t dt would be t square by 2 plus c, which is going to be log sin x to the power 2 by 2 plus c. Now let's do the next important question, 32 of this exercise. 32 is given as 1 plus cot x. So 1 plus cot x integral. First thing we need to do is rewrite this. We can write down cot as cos by sine. So this would be 1 by 1 plus cos x by sin x. Let's take the LCM now. So this would be, sine would go on top. It would be sin x divided by sin x plus cos x over here. So after this, the next step is we are going to multiply the numerator and the denominator by 2. So I'm going to write that half outside. And then this top 2 sin x can be written as sin x plus cos x plus sin x minus cos x whole divided by sin x plus cos x, and don't forget the half that's outside, and dx. So now you can split this up so that it's sin x plus cos x by sin x plus cos x, which will be nothing but 1 plus sin x minus cos x divided by sin x plus cos x dx. Now if we differentiate the denominator, we are going to get the same thing as the top, except there's a negative sign. So you would have cos x minus sin x over here instead. So that is what we can then use to substitute. So this half is nothing but integral of half would be x by 2, and this would be just plus integration of t could be sin x plus cos x. So then dt by dx would be cos x minus sin x. So over here dt is equal to minus sin x minus cos x dx. So this is going to be minus dt by t, and that's what we will be integrating. So x by 2 minus log t, log mod t plus c, where t is going to be sin x plus cos x would be your answer. So this is log mod sin x plus cos x plus c. Now let's move ahead to the next important question, which is question number 34 from the exercise. So this is root tan x divided by sin x cos x. Now, anytime you see such a question, you would have to convert one function to the other so that we can simplify it and then differentiate it. So, in order for me to convert this into tan, I would have to multiply this and divide this by cos, so that sin by cos becomes tan, and then cos into cos would become cos square x. So, that's what I'm going to do. This is going to be root of tan x divided by tan x times cos square x. If we take the cos square x, it becomes secant square x on top, and root tan x can be written as this would cancel and this would become a root. So this is secant square x divided by root tan x. So now you can figure out what the pattern is. Differentiation of tan x gives you secant square x. So your t value should be tan x, and then dt by dx would be equal to secant square x. So dt is going to be equal to secant square x dx. So let's integrate this now. So we are going to get integral dt divided by root t. So root t's integration would be t to the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 is going to be 1 by 2 plus c. So your answer should be 2 root t plus c, where t is nothing but tan. So this is going to be 2 tan root tan x plus c. Let me move ahead to the last question, important question from this exercise. That is going to be x plus 1 times x plus log x whole square divided by x. So now if we look at this, first thing that we need to do is figure out which function, if there's any function which is the derivative of the other. So I can see that x log x's derivative would be 1 plus 1 by log x. And I have x plus 1 by x. So let me just rewrite this as x plus 1 by x times x plus log x whole square dx. This can be rewritten as 1 plus 1 by x. So now we found what we were looking for, the derivative of x plus log x over here. So this can be your t value. T is equal to x plus log x. And then dt by dx would then be 1 plus 1 by x. So now dt would be equal to 1 plus 1 by x times dx. So I can rewrite this as this would become dt and this would become t square. So this is t square dt. Integration of this would be t cube by 3 plus c. T is nothing but x plus log x whole to the power 3 divided by 3 plus c. So this is going to be our final answer. If you found this video useful, do hit the subscribe button, like it and comment for what more videos you would like to see. Thank you.